Okay, hello to the course Information Visualization. Today is our first session. This presentation is actually going to be a short one. It's going to be a short kickoff to give you an overview of the course, the topic that we're covering, the different subjects, the structure of the course, and a bit of logistics, considering the situation as it's becoming to be known. The idea is that after this presentation today, you know what to expect from the course that is going to run over the next 15 weeks. You can kind of plan ahead. And I thought it might be good to actually start with a definition. So when we're talking about information visualization, what is it? The typically used definition is this one by Card and colleagues, information visualization being the use of computer-supported interactive visual representations of abstract data to amplify cognition. And it helps to actually mark up a few words here to explain what is meant. First, not actually highlighted, but we are talking about computer-supported visualizations, computer-supported representations. So there's going to be some use of algorithms and data and some kind of computer situation. Strictly speaking, that doesn't have to be the case necessarily, but here for the purpose of the course and have to keep a focus, this is what we are going to limit ourselves to. Then the first adjective here is interactive. So the idea is that these representations allow viewers, users, readers to explore patterns and relationships in a data set. And they're able to do this through interactive capabilities. Then we are particularly relying on the visual perception, the human eye, so that we can see patterns and certain visual structures, and we're going to actually learn a bit about that as well. We're looking typically at abstract data, so this is data that does not have an inherent spatial dimension. So the design of visualizations here require us to actually still define what is left, what is right, what is on top or below. So we actually have to design techniques or pick techniques that spatialize or use basically the X and Y coordinates of the screen. Last but not least, we're going to do this to amplify cognition, to support thinking, so that we can make meaningful and informative connections and possibly also inform decision making. So this is the kind of the definition up front. Of course, there are others that have been proposed. For example, information visualization being that actually uses computer graphics and interaction to assist humans in solving problems. Just if you look up Wikipedia today, it's being defined as the study of interactive visual representations of abstract data to reinforce human cognition. So somewhat close actually to the definition that we just had in the previous slide. Now, over the last, say, 30 years, the field of information visualization has emerged as its own area of study and practice, and actually a wide range of visualization techniques have been developed. They have been studied, so we actually have insights about perceptual and cognitive aspects of data visualization use. And lots of methods and approaches have also been proposed to designing and studying visualizations. And actually to look at a very kind of convincing case, I'm going to beam Hans Rosling into our presentation to share the joy of data and making it visible. Yeah, pretty neat, huh? This video is, I think, over 10 years old now, but especially with the reference to the Spanish flu, of course, it's quite current. And it is a very succinct and convincing example of data visualization, especially when animated, and of course also combined with with a narrative, with such an engaging person as Hans Rosling was. There has actually been also an interactive version of the same visualization that you've seen. So actually the Google Public Data Explorer allows you to dive into similar data and look at kind of the temporal development. So in this, you can actually set different filters and dive into subsets. Now, why do we visualize? I mean, you're taking this course. There's lots of interest actually in this topic. So typically, the community distinguishes between two main reasons. On the one hand, we want to explain with data visualization, with information visualization, which I'm actually going to use interchangeably, if you wonder. So explanation meaning that we're communicating insights, we're trying to inspire new thinking about a problem, and also inform decisions. But what explanation already requires is that the person who explains something already has discovered these insights, so they're basically communicating them. So on the other hand, data visualization, information visualization, visual analysis is also used to support exploration, so that in the case if you don't know what a data set contains, that you can take these different perspectives, try to analyze, understand different patterns, possibly complex and multidimensional patterns, and reveal relationships that you haven't seen before. These two reasons or purposes of data visualization can of course also can be stretched out and elaborated a bit. So on the one hand, very simply, we have dissemination, that we're actually just stating simple facts. If we increase the detail, we're actually supporting observation. We might want to also include description on what, when, and where something happened. If we go a bit deeper into analysis, maybe we want to understand how two phenomena, two aspects of a data set relate. And maybe we also want to model it and understand what actually drives what. So if we actually have information on temporality, we can try to explore what has caused something else. So this is a bit of a more nuanced explanation of this spectrum between explanation and exploration. Now, another kind of motivator why it might be useful to plot data, to visualize data, is actually the Anscombe's quartet, which is simply the idea if we have 4 data sets. So here each of the Roman numerals 1 to 4 actually contains x and y values, each 10 of them. And if you just look at this table, you will have a hard time to actually understand or pick out how they differentiate or how they are similar. And if you apply some simple statistical description, such as averages, variance analysis, correlation analysis, you will actually find out that these 4 data sets are statistically equivalent. So they actually all look the same. If you look at this kind of statistical overview, it is only with plotting these data sets onto just a scatter plot, so actually mapping out x and y, we see that they actually look quite differently to each other. There's of course the conviction that, and that's actually part of the definition, that information visualization can amplify, so support and help cognitive processes. And how can it do that? And there are a few reasons that we can think of. So first, it actually increases our mental resources, our capacity of both remembering something. So our working memory is actually extended because we're actually externalizing part of the data or the information that we're reasoning about. And we can also do parallel processing because our visual system actually can scan fields and can see patterns in a non-linear fashion. It also allows us to reduce the search in the sense that we can actually quickly get an overview of a high density, high data density display and spot outliers or particular patterns that we want to find. And pattern recognition is another reason or another mode of supporting cognition, in the sense that data visualization actually allows us to abstract and aggregate large data sets into shapes that might be more accessible or more informative than if we just had, for example, very long tables. We can make perceptual inferences, so relationships between different data dimensions might become more visible and thus maybe more obvious. We can also monitor changes over time, so we can see how trends are developing. This is of course very current right now, as we are constantly checking the numbers of cases and deaths due to the coronavirus epidemic. And then we can also support cognition through interactive manipulation, so that there are actually ways of adjusting parameters, setting filters, changing views, so that we can actually make sense of a data set and thus also of an issue or a phenomenon from different perspectives. Now, information visualization actually draws from several areas of influence. And to be honest, this is also part of the difficulty that you might have actually in some assignments or in working on your data dossier, or whenever you're actually working with information visualization, when you're actually creating them. And that is because it actually requires technical, aesthetic, conceptual thinking and experience and insights, so that the information visualizations that you're generating are actually insightful. So of course, cartography has had a long history of generating visualizations, in this case spatial visualizations or geo visualizations. I already briefly talked about the statistical descriptions of data, so we're also relying heavily on statistics. So actually here it would be good if you have a bit of experience with statistical analysis. We're also relying on perceptual psychology, so we understand how our eyes and our larger visual apparatus actually perceives shapes and patterns and color and forms and so forth. We're also mobilizing computer graphics, depending on how sophisticated or how intricate the visualizations are. Of course, they are going to be printed or rendered on the screen, and they might involve some heavy lifting, depending on how intricate they are. There's also, of course, human-computer interaction, so the study of things like user experience, interface design, usability. So actually, the relationship between humans and computers and how this can be supported. And also graphic design, so actually understanding things like the Gestalt laws and how typography fits in and so forth. So color choices and so forth. So and that's kind of like a small set. There are definitely also other areas of influence. If you now think about the rise of machine learning and related methods. So there's, of course, an exchange between these different areas of research and practice. Now, information visualization also has quite a lot of application areas, so domains in which visual analysis and visualization actually play a growing role. So of course in science, in scientific communication, scientific research, charts, graphs, visualizations play a role in financial analysis, in the mapping of crime, data journalism. Actually, we're going to see, I think, quite a few examples from the context of journalism, where investigators and authors are also drawing on maps and charts and other visualizations to tell journalistic stories. In live logging, so some of you might be logging your sleep patterns or whatnot, and there we are also encountering visualizations. Also in the arts and humanities, we see actually quite a growth of data visualization use in this context. We see civic groups who are using data and visualizations and maps for their advocacy, and also in the context of city planning, of this larger sphere of urban futures. There we also witnessing a growing interest in mapping and visualizing data to inform, for example, planning processes, or understand how different sectors are working together. Now, actually, information visualization is has been quite a focus topic for the FH Potsdam, and especially our group in the UC lab. So both researchers and students have over the last years have been working on all kinds of visualization projects. And I wanted to actually, already in the first session, I wanted to show you a few projects from our own universities, so you get a sense of what's happening. Some of them are a bit more experimental, some of them are a bit more maybe conventional. And if you want, you can look at them in more detail. I linked them also in the slide deck. So I want to actually show you a few of these projects just to get you kind of maybe inspired to look into this. So here we have a project on the German Digital Library, who approached us already several years ago and wanted to kind of get an overview of their holdings of millions of different kinds of cultural artifacts digitized and made accessible online. And here we see like a temporal chart distinguished vertically along different sectors, archives, libraries, and so forth. And on the bottom, we actually have multiple faceted tag clouds for different entities. And you can actually filter it and see how different time spans actually relate or have different topics. A similar project actually we've done with the Georg Eckert Institute on textbooks, on school books. So here we also have actually a combination of a temporal visualization and different kinds of facets, but here we actually have little bar charts, and they correspond to temporal selections, and you can scroll further and actually see also geo visualizations and so forth. So this actually shows the distribution of publishers. We have done a project with the SPSG, the Foundation of Prussian Castles and Gardens, on drawings by Frederick William IV, and they are arranged in a temporal display, and you can actually zoom into high resolution scans. So this has been a project, is quite a technically involved project. I mentioned earlier computer graphics, so here it's actually really important to carefully engineer how the graphics are loaded into the browser and how the details are increased as you can zoom in. We've done a research project with the German National Library where you can look at the temporal distribution, the themes, the people that are in these holdings, and you can actually relate the publication history to the actually biography and lifespans of people actually in this large catalog. And you can also look at particular books. So this is quite a comprehensive interface. And more recently, we've done a project with the Fontana archive, and we looked at the reading traces that Theodor Fontana, a German author, has left in his own reference library. And the particular innovation that you see here illustrated in this video is that you can quickly and we think relatively easily can basically shift between the different granularities from high-level overviews to individual books and pages, and see how Fontane has marked them up with comments and notes and so forth. Here's a project that was actually done by a student team. They looked at a coins collection and how it distributes over different facets such as time and material. And what was unique about this project was that it actually uses the imagery of that collection. So it kind of gives that very haptic and visual feel that makes it very playful. And maybe a last project here, Airbnb versus Berlin, was basically a data dossier, so an article that looked at the Airbnb situation in Berlin, so how it distributes over different districts and which districts maybe basically had the most listings. So it's a combination of some writing and some relatively simple but useful charts. So there was also a price analysis done, and some just photography and some numbers and tables. So actually a kind of quite a mix of forms, the number of beds, and also how the top Airbnb users, how there are multiple flats basically distribute over the city, and also which, in this case here, in which streets most of the flats or listings were actually located. And with a quick cut, I'm actually moving into logistics. So this was just a quick overview of what has been happening. And of course, there are other activities as well to motivate and maybe inspire you to come to grips with information visualization. I am your instructor, as you will have guessed by now. I'm a research professor for information visualization at the FH Potsdam. So I basically think and do InfoVis most of the time. You can always reach me by email, and we will get to other means of contact in a bit. The sessions of this course are scheduled to be on Thursdays from 2:15 to 5:15. And I believe we also have a room actually reserved to us. But for now, we don't actually know when the semester on site, on campus, will actually start. So for now, I am planning for an online semester. So for that, the schedule looks slightly differently. So to give you a bit more time, I plan to upload lectures as the one you're listening and watching right now, together with tutorials, always on noon on Thursday. So at the latest then, maybe already a bit earlier. Because the course would start at 2:15 and you might have other activities beforehand, I would actually wait a bit until we start with the video conference. So I would suggest that we start with 3 p.m. To actually have our weekly check-in via Zoom video conferencing. This way you can already listen to the lecture and maybe have a look at the tutorial. Depending on what you have before 2:15, you probably will have enough time to actually work through the tutorial as well. The course is set up so that it addresses students from the information sciences, so library, archive, and documentation in the VABD module. It also addresses BA students in design, especially interface design, and also master students in the Urban Futures Masters, so they can earn credit in their fachliche Vertiefung or Wahlfach. For now, there are three important links. I think the first one you must have clicked already, otherwise you might not have reached this video, which is the Moodle workspace. This is where the lectures, tutorials, and assignments will be shared. So this is basically the central hub for this course. The Zoom meeting for our weekly check-in at 3 p.m. on Thursdays has also a fixed link. The link stays the same from week to week. And I have created an empty Google Doc in which we can share links and notes. We can do this during the check-in, but also if things come up during the week, things you want to share with the other students, you just want to note, feel free to leave them there. So this is kind of the basic logistical infrastructure. The learning objectives that I've set myself and of course more importantly yourself are the following. So first I want you to familiarize yourself with the perceptual and conceptual foundations of information visualization, gain practical experience in data processing and visualization creation, learn about most of the established visualization techniques for common data structures, in particular with regards to text, time, geospatial data, multidimensional data, and network data. And we're going to also, I think, flex the critical muscle. So you should also learn how to interpret and criticize information visualizations, so question how they were made. And this is not a theoretical course in the sense that in the end you should be able to design and prototype information visualizations for a given data set. And maybe as a very current motivation, we are in need of good data visualizations. So here we have a still from a television screen in the United States. If you look closely, you see that the pie chart, which should always add up to 100%, kind of goes, takes extra circles. So maybe this is something you would have caught also without taking this course, but maybe just to underline that we do need InfoVis experience and expertise out there in different contexts. The class format is going to look like this. So first, there will be lectures that I pre-record, and they will cover fundamental principles and methods of information visualization. I am pre-recording them so that you have enough time and you can download them depending on your internet connection. Actually doing this live might not be so useful because, I don't know, the video quality might not be so good and whatever. You can, in this way, you can press pause and take your own time. So this is the lecture component. There are tutorials which are going to be written in Jupyter notebooks. We'll get to that in a second, on data wrangling, basic interaction, and visualization techniques. And they are hands-on, therefore the hand, in the sense that you can actively, and you're encouraged to actively follow along by changing things around. So the notebooks are interactive documents in which you can actually change the code and try things out. There are going to be 4 assignments at the very beginning of the course, so of the course of the next 4 weeks, and they are not very difficult. They are meant to be warm-up activities on collecting and visualizing data and interpreting information visualizations. So this is, and they will not be graded. I will just ask you to do all 4 of them, but they will not actually inform your grade. What will be graded is going to be the data dossier. So a report on a specific topic that includes data preparation, processing, and presentation. And we'll get into this in a second. But the data dossier will also be written in Jupyter notebooks by yourself. And then that's maybe the most live component of this course, our weekly check-in via the Zoom conference. in which we're going to have a conversation about basically open questions, feedback that you have or feedback that I have on your assignments or on your dossier, suggestions that you want to share among yourself, with me, whatever. So this is important for us so that we actually get together in this course. Basically, all the other components, the lectures, tutorials, assignments, and the data dossier, they will happen in a way asynchronously, right? So the check-in at 3 p.m. on Thursdays is going to be important so that we mimic a bit of a classroom situation. Now, all of this might be relatively clear, except maybe the data dossier. So a data dossier, in my view, is a brief article reporting on a specific topic through the use of a dataset, its analysis and visualization. In other words, the data dossier is your semester project. So you can do this individually or as a group of 2 or 3. And early on, you basically choose a topic and very soon also a dataset or multiple datasets. And that should basically resonate with your own interests, maybe also expertise. Typically, it helps to pose a question at the beginning so that this will drive your work and help you apply your visualization skills that you're acquiring in this course. You will be asked to generate several visualizations. Some of them may be static, some of them interactive. And in the report, in the data dossier that you're sharing, you will include the most informative ones. You might actually generate more than need to be in the data dossier. In kind of experimenting with different forms, you might throw some others out that might have not been so useful. And in the end, you will share the resulting report with the class and with me as well. There will also be a feedback situation actually where you look at each other's notebooks. So that is the data dossier. This is kind of what we're working towards. And here is the semester plan. As I said, the main components are lectures, tutorials, assignments, and the data dossier. The lectures start easy, as today, and are typically around, I would say, half an hour. Sometimes they might be a bit shorter, sometimes a bit longer. So we'll start with some basics, a bit of history, some foundations in terms of perception and interactivity. And then we will have 5 sessions on particular data structures. Temporal and textual data, multidimensionality, relationships, and space, in the sense of geospace. And then we have a few more inputs on collections, design, process, and evaluation. And basically the tutorials, they do not exactly fit the lectures. So we will have the first tutorial next week. For now, we will we start easy in this week, and with regards to the 5 lectures on different data structures, time, text, multidimensionality, relations, and space, we will also have respective tutorials that cover these kinds of data structures. You will have a few assignments early on. Again, they will be simple, and after once April is over, I ask you to focus on the data dossier, and there, and we will practice this in the tutorials and also in our conversations. I'm going to suggest kind of a 3-step process of preparing, processing, and presenting data. And in the end, there will be time for some peer feedback. So you will be able to look at least one other notebook. Ideally, everyone looks at all the other notebooks or data dossiers to give feedback to each other. So there's enough time to refine and finalize your dossiers. And the last session, I don't know if typical, because nothing will really be typical this summer, but the last regular week will be or the last session will be on 9th of July. And then you will have one more week to finalize and hand in your dossier. So that's the that's the semester plan, and I already mentioned it. We are going to work with Jupyter notebooks. They are documents that include code. They can be run on Colab, which is a Google platform. So you don't actually have to install anything on your local machine, but you can actually run it in the browser. And I will show you a brief video in a second. And the programming language is going to be Python. So for the code segments in the Jupyter notebooks, you will be reading and writing Python code. Now, how does this look? So here, if we're in the Moodle workspace, you scroll a bit down, you see my hello video and some details. And here for the first session, and I noticed that I already linked the tutorial there, so you will actually have the tutorial already in the first week, and you can open it up on Colab on Google, on the Google platform here. And if you actually want to run it yourself, also on Colab, you need to log in. Otherwise, if you don't have a Google account, or if you don't want to log in, you will only be able to read it, and you would have to download it to run it on your local machine with the Jupyter Notebook installation, such as, for example, via the Anaconda distribution. But here in the browser, it would be possible to basically run each of these code cells. So these are these it's these cells with the light gray background. And if you open it up, you can also see the source also of the text segments, and of course the source of the code segments is always visible. Yeah, and already the first tutorial will have a bit of visualization action. So here we are actually importing a library called Altair. This is something that is already available on Colab. If you run this locally on your machine, you might have to actually install it, either in the Anaconda package manager or via the console, depending on what your setup is. And here we are loading actually a data set on different countries and their populations, and we are mapping this into a scatter plot, actually an interactive scatter plot, where you can see countries mapped to area size and population. So this is the first tutorial that I invite you to check out and read carefully and play around with. If you also want something on paper or something actually physically, like a book, I can recommend these books here by Isabel Mereis and Tamara Wanzner. They're not required readings, but they are very much worth the read. And if you do like to actually have a book accompanying this course, I think these are the ones that I would recommend to you. What is also recommendable is that actually the visualization community is a very active community. So there are multiple blogs, so actually Multiple Views and Nightingale have been recent additions, where you have regular features on InfoVis topics. Lots of visualization folks from academia and also practitioners are lingering on Twitter and sharing projects and insights and so forth. There are different awards and competitions. There are some podcasts you can listen to. There are meetups. They are not, I guess, right now not active in the Corona situation. But if they come back, I would definitely recommend the DataVis and MapTime meetups in Berlin. We actually run a talk series. So if you want to hear some other speakers talk about InfoVis, this is also a good spot. There, of course, there also have been exhibitions on information visualization and conferences. Many of the software tools are open source, and some of them that are not open source are freely to use. There are also many software libraries. We're going to start using Altair in the Jupyter notebooks. And the visualization community has also different kind of online manifestations that are worth checking out. Now, I think this should be it for the kickoff. That leaves me with just the first assignment. So the way just how I said hello to you in my little video message, I'm going to ask you to do something similar, to post on Moodle a brief message with a short blurb about your motivation, why you're taking this course, a photo of yourself helping me and of course yourself to remember all the names of the students in the course, and one visualization that you find particularly informative, inspiring, and or innovative. And I'm asking you to post this hello message to Moodle by next week, Wednesday, the 8th of April. And this is it for now. Thank you for listening.